Hey everyone, Unit 5 review coming up. You might be wondering why I have these as my background. I scored World Cup tickets. Woo! Won a draw. Curacao, no, Curacao versus Ivory Coast. Let me know who you think I should cheer for. Curacao, a small island nation off the coast of Venezuela. Ivory Coast, I think West African nation. I know in Africa. But anyway, more familiar with Ivory Coast than Curacao. So I'm not sure I'm going to root for it, but I'm going to the game of the World Cup. If you're not a World Cup fan, Google it. Anywho, I'm excited about that. I want to share with you my excitement. But I know I'm excited about the World Cup, but I bet you guys are excited about the Unit 5 review. So don't worry. It's not all soccer talk today. Here is Unit 5 review problems. I might be going a little fast for a lot of you, but remember, stop. You should try these problems on your own and then watch the review. Slow it down if you need to, skip the ones that you got right, and just move on. Okay, so F of 1. So you're working with the, why did the pen just turn off? There it goes. And now we can erase everything. Okay, you're working with function F. Oh, it's because my bar is blocking. Oh, really tough beginning to semester 2 here. Okay, so we've got the F function. So with the F function, does that happen every time I go to the top part of my screen? Okay, 5, you're replacing the X here in this function, the top function there. Make sure I am definitely recording and sharing. Okay, so this would be 9 plus 5, which is 14. Switch colors for the next one. We go to function K here. So K of 21 equals 21 over 3 because I'm using this function because it says to use K. Okay, classic. Okay, so 21 divided by 3 is 7. So there's my answer. F of 0, again, when X is 0, this is a very important point on your graph. This is when X is 0. This is your ding, 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 Y intercept. Because 5 times 0 is 0. 9 there. I don't even know what that bell's for. Maybe you guys can't hear it. All right, so you were given X with your functions. Now down here, these f of X and K of X's, these are just fancy ways of saying Y equals this. So you have 19, you're trying to solve this in the equation f of X equals 19. So you're doing 19 equals 5. Let's make that more clear that it's a 9. Oh my gosh. It's 5x plus 9. Take 9 away from both sides, and you have 10 equals 5x. Divide by 5. 10 divided by 5. X equals 2. The next one, again, we're back to the k of x function. So you have negative 2 equals x divided by 3. We got to get rid of that 3 by multiplying by 3 on both sides. You have negative 6 equals x. I hope you guys don't see this bar that I keep having to move. It's pretty annoying. All right, g of 3. That's just asking me where what y is when x is 3 on this graph. So go to where x is 3. Boom. Find it. It's 2. Same thing here, but you're using negative 2 as your x. Negative 2 is x. Go down to the y. Make sure to keep the x's and y's straight. Got negative 3. Which is greater, g of 0 or g of 4? So at 0, there, 4, my class said they did not think these were equal. I think these are equal. If you saw something different, okay, just draw it in a way that it makes it clear. But I think they look equal, at least on my drawing, they look pretty equal. But if you can prove otherwise, at least make sure you can prove it. Identify the max. Now, this graph goes into infinity. So I guess if you're saying, okay, the max, there's no indication that it ends here and that it just keeps going. I would say, though, we're probably talking about the local maximum here. The local max here being the highest peak. The X value there, I don't know, somewhere around approximately, it's kind of an approximation here. So I will say, I don't know, about 0.8 for my X and 6 point, let's call it 6.2 for Y. The minimum, we don't need a local, this is a local minimum, but we're just going to the absolute lowest value here. Absolute lowest value is when X is -2, let's call that point. We said 0.8 there, so let's call this -2.9. And a little past 5, not quite to 5.5, I would say probably -5.2. All right, in this equation, make sure you read the whole sentence. 3 is replacing the t, which is replacing the time. So what we're saying here is that when this child is 3, what are we talking about? Months old, right? 3 months old. It weighs 5, not pounds, kilograms. Okay, on that same theme, I suppose, like what is the 2 representing here? Is the 2 the distance or is 2 the hours? Well, go to, this is replacing the x. And on the x-axis, we have we have time. Okay, so we're saying that in a sentence that in 2 hours, the motorcyclist motor has traveled 75 miles. Be specific. The more specific you are, the more right you will be. The more you understand what you're looking at instead of just looking at a bunch of numbers and being like, ooh. What's happened between 2 and 3 hours? Well, at minimum, we have to say if the distance is not moving, time goes on, time never stops, time continues, right? Time's a flat circle. The time goes on between 2 and 3 hours at the distance. It means at minimum, he stopped. Why did he stop? I don't know. Maybe he had to eat, go to the bathroom, go sightseeing, change bandanas, get gas, etc. All right, what is happening here? When f of x equals 100, x equals 4. Well, go to where f of x, fancy way of saying y. Go to 100. Is my time 4 hours? Yes, it is. That is true. Okay. The domain, we're talking about x values here. So at minimum, you would need to state that your domain, we're looking at greater than or equal to 0. We're looking at positive numbers for time. We're not going back in time. Okay, you're not Marty McFly. It ain't happening. Doc Brown. So a complete answer, though, I would say includes the minimum time, which is 0. and the maximum amount of time, at least on this trip, which would be 5 hours. The range, again, minimum, you can't go negative distance here. You're going to be going greater than or equal to 0, positive numbers. If we're being more specific for this specific trip, our lowest distance is 0. Our highest distance on this trip was 125 miles. Onward. All right, let's look at our domain here. So how I'll explain the domain, we're going from left to right on the graph. Okay, the actual line, that's not a very good line, right? So your domain is the beginning and end of your x values. So the beginning of your x values here, not on the graph, but the line itself. This lowest value is -5. We've got a filled in dot, so we need it less than or equal to x. The highest x value we get to is 7. So that's your domain. Your range, you're looking at vertical distance. So you're looking at how high is the highest, how low is the lowest. Okay, so maybe draw that line there and say, okay, going here to here. The lowest y value we have there is -2, less than or equal to y, and y is going to be less than or equal to 4. That's your range. These dots compiling over here because every time I have to move the bar on my end to move my picture around, I have to make a dot. Okay, same thing here. My domain, that's my x values. The lowest x value you have here is -1. Why'd I write -7? I don't know. The highest x value you have is 2. Again, we're talking about not on the graph you're looking at, but on the line within the confines of this grid. Okay, your range, the bottom, get your Drake on. Started from the bottom, now we're here. That from the bottom, not a oh, damn it. I don't know. I used to go to school in the neighborhood Drake grew up in. I wouldn't say he started from the bottom. I'd say he started in the middle. Pretty good neighborhood. Bottom of the music industry, maybe. Anywho, moving on. Okay, looking at these two, they should be pretty quick. We got graph B here. A, how do we know? Well, Sarah drives home. Sarah's driving, then she stops. That's what here's the stopping. We're flat, right? There's 2 moments of stoppage. That's what gives it away. So Sarah stopped. Can I spell? Good Lord. All right, how long was this person snorkeling underwater? So in this case, we're going to look at this graph and say, okay, positive numbers are above the water, negative numbers are below the water. Okay, so, well, if you're snorkeling, how are you going to be above the water? Well, when you get out of the water and go to the boat, that's an instance. And then, so why do negative numbers make sense here? Because you're going to be under the water. Okay. And then we're thinking, so we're under the water, we're going deep, going up, going down, and then, hey, time to get back up. So just understanding the context of what's happening here. So how long were they snorkeling? Pay attention here, underwater. That's how long were they in the negative range? For 12 0.5 seconds. How deep did the person go underwater? Okay, so just to be clear here, we should be looking at time on the x-axis and depth. See how well I can write sideways. Depth on the y-axis, and we're measuring it in meters, I believe. Let me double check. Meters. And I shouldn't have said seconds because we're measuring time in minutes. So I stand corrected. How deep did the person go? Okay, there's 1, 2, 3, 3.5. Maybe it should be beyond 3.5. So I don't know. I would say 3.75 meters. What does 13, 1.5 mean here? All right, let's go 13, 1.5. So that would mean 13 minutes into the trip. Person is 1.5 meters above water. Why would that be? It is probably nice to point out that this person is now standing likely on a boat or the shore, standing on surface. The domain of this function, so we're just looking at x values, right? We start at 0, less than or equal to x. That's when we start. And if we can see all the way up to 15, 16, but the trip ends at not 13 seconds, but 13.5. I said seconds again, 13.5 minutes, minutes and meters. Speaking of meters, the range of this function, we just said the deepest we go is 3.75. So that number should match where we say our lowest y value is less than or equal to y, and y is less than or equal to, go to the height, kind of drew on mine there. I can't quite see it. I think it's at 3. Yes, looking at the paper. Hey, piecewise function. Something we all strive to be, to have peace and to be wise. All right, I like to look at these as driving directions. This is telling me what rule to follow when I drive there. Well, maybe my example is not working that well. This tells me where to go for the x, and then I follow a rule for the y. Okay. G is -5. G of -5, that's saying when the x is -5. So find the rule where -5 would apply. -5 is not greater than 4. It's not between -3 and 4. It is in fact less than -3. So I need to follow this rule for number 1. And I need to say, okay, I need to plug -5 into that equation. -5 plus 5 equals 0. So my answer here, 0. So I had to follow. Let's make, every time I have to follow that rule, we'll do it in green. Every time I have to follow this rule, I'll go in red. And every time I have to follow this rule, I'll go in blue. Okay, for number 2, it's -3. Careful with this one. -3 is not less than -3. -3 is equal to -3. So we need to follow rule 2, aka the red rule. 2 x of -3 minus 1. 2 times -3 is -6 minus 1 is -7. Okay, what about 0? 0 again falls in this red rule. 2 times 0 minus 1. 0 minus 1, which equals -1. So -1 is my answer there. 4. All right, this says x is greater than or equal to 4. 4 is not greater than 4, but it is equal to. So these look tough because there's nothing to do really, and sometimes accidentally we plug some things in. This is just saying that this number is the y. 8 is greater than 4, so therefore, again, my y is -6. All right, reading these graphs, let's just see where we're at when we get to these given x values. When I go to 3, when x is 3, y is 1. When x is -4, y is -3. When x is -1, see that open circle, be careful. The open circle means we are not there, so I should be looking along this line until I see a dot. Boom, there it is. 1. Bada bing, bada boom, as Miss B would say. You all don't know Miss B yet. When you do, when you meet her, she'll say bada bing, bada boom. All right, 0 is x, 1 is the y. So we can have y values multiple times. That's fine. We just can't repeat the x with different y values. When x is 2, another example of y being 1. Go to where x is 4, y was 0. Okay, graphing these, I'm not going to act like it's the easiest thing in the world, but let's also not make it the hardest thing in the world. Let's clear some of these dots. Okay, do this one in blue, the second rule in green, third rule in red. Reminds me of the Olympic rings. Hopefully you guys are watching the Olympics. Let me give it a try here. Is this what they look like, the Olympic rings? There's 5 of them, right? Yeah, we need some other colors. Anyway, let's focus. Focus, Cunningham. All right. When x is between -5 and -1, the y value, so the y value, this is the x value. So between -5 and -1, right, this range, this domain, I should say, then my y value is -3. So down here, remember, this does not equal it, so I need to have an open circle here. Okay. And then this goes all the way until x is equal to -1. I can close my circle, -1. Now this is saying my y value is going to be 2. Once I get to -1, I can hop all the way up to 2. Open circle, you can't exist in 2 places at once, so that open circle needs to be there. And then draw a flat line all the way until we get to equal 4. Again, close circle there. And I'm going to hop to the y value of 6. Open circle, make it clear that it's an open circle there. And then my line should go all the way to my maximum of 8, where there should be a closed circle. Okay, important to note here. What transformation is going to happen here? Okay, so just to be clear, a regular absolute value function. So f of x. I'm just going to draw f of x on this graph below to show us what our standard absolute value function looks like. Okay? And we can apply this to both problems. Our standard absolute value function has a vertex of 0, 0. This one, g of x, if I were to draw this down here, it doesn't ask for me to draw it, but I just want to point out that this +1 is it's going to do the opposite inside the parentheses. So it's going to move me to the left one. And then this is going to do exactly what it says, and up 4. Okay, so what would that look like? I'm going to try a little experiment here. If I went left 1 and up 4, 1, 2, I would have a line that goes like this. All right. So that's for number 22, right? That's what this would look like. That +1 moves me the opposite along the x-axis, and then the up 4 moves exactly what you think is going to happen for the y-axis. Okay, the reason I put that different one is because I think I can erase that. Yes, I can. Okay, and move on to the next problem. Look at me getting all sorts of, oh, I gotta switch away from annotate. Now I can switch to this problem. Okay, so now I'm gonna graph this next one as g of x, like the paper says to do. Again, we're comparing it to your regular absolute value function. So your regular absolute value function, again, your absolute value of x, that's what it looks like. G of x, we're saying this left. I know when it says, I even just said left. When it says minus, you're thinking you want to go left, but what happens is the opposite happens inside these parentheses. So we're going to say this goes to the right 3 and down 2. So we would have a vertex. Right 3 would be +3. Down 2 would be -2. So go to the right 3, down 2, and then just draw your exact, just draw your v with a slope of 1, your absolute value function. See, I like that previous line feature I was using. It makes my lines a little straighter there, but you should have, what happened is it moved right 3, down 2. Okay. So what explains here, 4, again, 4 is going in for t. So M4 equals 20. That's saying that 4 minutes max travels 20 blocks. Okay, if he's driven for 100 blocks, again, the blocks is the M, so we would say 100 is 10 t minus 20. So we need to solve here, excuse me. Add the 20. So we are solving. So you're solving, but you need to explain what you just solved for. You just said that, hey, 12 equals t. What does that mean? Max or 12 minutes. All right, let's look at this last graph. This is basically dynamic pricing for a party. Okay. The number of people at the party is represented on the X. So basically, if you have less than or equal to 10 people, you get a 50. You have to pay $50 for that party. Okay, small party, smaller amount. Are you going to pay anything for a if no one shows up to your party? Well, I hope not. Hope some people show up. So open circle all the way till you get to 10, and it should close there. Okay, green, blue, for as soon as that 11th person shows up, so more than 10 people, we're going to be paying $100. Do that until you get to 15 people. If 15 people show up, more than 15, I should say, as soon as that 16th person shows up, you need to be at 175, which is right in between 150 and 200. It's not, oop, that should be an open circle. And that goes all the way to 30, where we have a closed circle. And then this graph doesn't go all the way to 40, but that's okay. We can just say, we can hop up to 200 right here. And it's going to go on. Well, maybe I'll draw an arrow to say it's going to go on until 40. 40 is the most people you can have at this party. Okay, so how much does it cost to have a party with 15 people? You can use the table or the graph here. 15, I see 15 here. It's $100. I can see it on my graph too. 15, still at 100. Ooh, I guess that should have been 8. Halfway between there would be 14. That one should have been moved over a bit. My apologies. So shift that. My bad. But either way, you should be able to find 15 would be 100. So let's wish I could do a quick fix on that. Use your table to see that if 15 was the number, we'd be at $100. How much does it cost to have a party with 24 people? Well, the graph is a little better here because it's actually accurate. 24 gives me cost of $200. You could also find 24 between 15 and 30. Or sorry, that was the 175. Oh, got me thrown off here. And I guess this should tell everybody, double check your work. Good luck on the test. Ooh, I just stopped my video. All right. Stop recording.